Welcome to the TOEFL Listening section. In this section, you will listen to an academic lecture and then answer questions about what you heard. You may take notes while you listen. You will have time to review your notes before answering the questions. Listen to part of a lecture in a university class. You will hear the lecture only once, so listen carefully. After the lecture, you will answer some questions about what you heard. Some questions ask about the main ideas and supporting details. Other questions ask you to make inferences or connections between ideas. Answer each question based on what is stated or implied in the lecture.
Good morning. Today we will examine ancient ceramic techniques with a focus on glazing and firing methods across cultures. I want to approach this topic by comparing how different societies solved the same technical problems of making a stable surface on clay and achieving color through heat and chemistry. We begin with the most basic firing method used in the Neolithic and later periods: pit firing. Potters stacked pots with combustible materials in a pit and controlled the burn to reach low to moderate temperatures. Pit firing often produced smoke effects and incidental ash deposits, but rarely reached the temperatures required to vitrify clay. From pit firing, ancient communities developed kiln technology. Updraft and downdraft kilns allowed better temperature control. In China, the development of long, sloped dragon kilns enabled much higher temperatures and longer firings, which were essential for the early stoneware and later porcelain traditions. Kiln atmosphere matters. An oxidizing atmosphere provides plenty of oxygen and tends to yield bright, stable lead glazes. A reducing atmosphere limits available oxygen and can transform copper compounds into that characteristic green or blue-green seen in celadon ware. A concrete example is Chinese celadon. Song Dynasty celadon relied on a reducing atmosphere combined with precise control of temperature to produce a jade-like green through partial reduction of iron oxide in the glaze. Another important case is Tang sancai. These are lead-glazed earthenwares with vibrant polychrome glazes. Potters formulated lead-based glazes that melted at lower temperatures, which allowed bright colors on relatively low-fired bodies. In the Mediterranean, the Romans used lead glazes to create glossy tablewares. Their kilns were efficient and could be used to produce lots of similar items, which tells us something about standardization and craft organization in ancient societies. Let me highlight a non-clay example that nonetheless informs glaze history. Egyptian faience is a silica-based material, not strictly clay. It was made from ground quartz and self-glazes in a process involving alkali fluxes and careful drying before firing to create a bright blue or green surface. Glaze chemistry is about flux, silica, and alumina. Fluxes lower the melting point of silica. Lead and alkaline materials act as fluxes. The ratios determine whether a glaze will be glossy, matte, runny, or stable during firing. Ash glazes are noteworthy. In early Chinese kilns, wood ash from the fuel fell onto pots and melted slightly to create a glassy coat. Over generations, potters refined the process to intentionally mix ash and clay to make controlled ash glazes. When I say that ash glazes developed in ancient China when potters noticed wood ash melting onto vessels in wood, firing and forming a glassy coat, I mean to emphasize how discovery often came from observation and repetition rather than theoretical chemistry. Another technique is application method. Slip and engobe are liquid clay layers applied under or over glazes. Terra sigillata is a fine slip, burnished to a sheen before firing. These surface treatments influence how glazes interact with the body during firing. We should also consider thermal profiling. Ramp-up speed, soak time at peak temperature, and cooling rate all affect glaze behavior. Slow cooling can promote crystallization in glazes, producing effects like crystalline glazes, known in later historical periods, but rooted in ancient experimentation with cooling regimes. Finally, let us think about cultural transmission. Techniques traveled along trade routes. For example, the idea of lead glazing had parallels in the Roman world and later in Asia, adapted to local materials and firing systems. In summary, ancient potters developed a range of glazing and firing techniques, from accidental ash deposits to carefully controlled kiln atmospheres. These methods reflect the interplay of material science and craft knowledge across cultures. That concludes the lecture. We will now look at specific kiln cross-sections in the next session.
Listen again to part of the lecture, then answer the question.
When I say that ash glazes developed in ancient China, when potters noticed wood ash melting onto vessels and wood firing and forming a glassy coat, I mean to emphasize how discovery often came from observation and repetition rather than theoretical chemistry.
This concludes the listening section. For more TOEFL practice tests and study materials, visit spinta.org.